Good morning.
Yes, sir.
So as we know, if you are knows that already we are studying, we started yesterday of fluid pressure, means the pressure exerted by fluids. So we are having basically fluids means the substances which will flow. So we are having two kinds of substances. What is that substances, anyone? That is what we used to call as liquids and as well as
Liquid
what?
and gas.
Gases. So this both together we used to call as fluids. Now, in last class we derived the derivation for a pressure exerted by fluids. That is what finally we have been made. The pressure exerted by any fluid is equals to density of fluid into next height of the fluid in the container, height of fluid in container into what, guys? Last one, into acceleration due to gravity. So this is what the formula which we used to call as liquid pressure. Is it right or wrong? So the pressure exerted by solids. So we studied before class, pressure exerted by solid is equals to what is the formula, guys? All of you. Force by area. Now, the pressure exerted by fluids, we are studying that rho into G into H. Basically, of course, I have changed here, so you can change it. Rho H and G or rho GH. Or rho means we can represent with the D also. Density into acceleration with gravity into height. Any doubt in this? Now, as I told you, units, formula might be varies, but units of pressure is always ultimately same. Can anybody tell me what is the units of pressure? I want the units of pressure, all of you. Units of pressure is what? Yes, Mitakshri, Raja, Abhirami, which
Pascal,
is
sir.
Pascal. So Pascal, and as we know, 1 Pascal is equals to how many square meters? 1 square meter, 1 Newton per square meter. So that is what we studied. Now, from this also we should write the same units. So let us make it. So remember all of you, units of density is kilogram per cubic meter. Is it okay, guys? Because density is equals to mass by volume. Mass unit is kilogram, volume unit is cubic meter. Is it okay, everybody? Kaushik, Aswin? Now, next. Acceleration due to gravity. Can you tell me what is the unit of acceleration due to gravity? Meter per second square. Same way, height unit. I want unit of height. Height will measure how? Meters. Okay. So know this one and substitute it in this formula. So let us see the units of fluid pressure is same or not. So here a smartness we have to be. So kilogram per cubic meter into G, meter per second square into next one, H, meters. Is it right or wrong? Yes,
Yes,
or
sir.
no? I want the answer from you all. Okay. Now, can anybody tell me 1 Newton is equals to how much? Let me see who will say first. 1 Newton is equals to something. Who will write?
Newton per meter square, sir.
1 Newton is equal.
Newton per meter square.
1 Newton equals to.
Kilogram per meter square.
Newton per meter square.
That is what I am expecting. 1 Newton is equals to 1 kilogram meter per second square. Is it right or wrong? Do all people knows or don't know? Yes? Yes, Mr. Omar? That is what you have to remember it. Now, here, basically, ordinary,
Yes, sir.
if you are not having a proper awareness, then basically what we'll do, 1 meter and 1 meter will get cancelled, 1 meter and 1 meter will get cancelled. Yes or no, Hari? So finally, we will say it is kilogram meter second square. Is it the unit of pressure? Is it the unit of pressure?
No, sir.
What is the unit of pressure? Unit of pressure is what? Newton per square meter, which is equals to Pascal. Is it yes or no, Mitakshri?
Yes,
Yeah.
sir.
That is what. So nobody can supposed to cancel. That is what you have to be enough smart here. Nobody is supposed to cancel this m, a 3m and here 2m, and you can write m. Now we can see. Can I write kilogram meter per second square is equals to how much, Hari? Just now I said kilogram meter per second square is equals to what? All of you. Newton. So
1 Newton.
of this entire thing, I'll write Newton into meter divided by cubic meter. Now I will get cancelled 1 meter and here 1 meter will get cancelled. 2 is remaining. So finally, what is remaining? Newton per square meter. So which is equals to what, guys?
Pascal, sir.
Pascal. Have you attended the same unit, everybody? So pressure exerted by solids or pressure exerted by liquids doesn't matter. Always, what is the unit of pressure? Is pascals. That is what you have to remember. And Pascal is equals to Newton per square meter. Is it okay, Harizeras? Kumar?
Yes, sir.
That is what. So any doubt, please kindly ask me. Solve it now. This is the units of pressure.
Yes, sir.
Clear, guys?
Yes, sir.
Yeah, do it. So you should remember solid pressure is force by area and liquid pressure is what? Rho GH. Density DRLs you can, you want DGH you can remember. DGH. Harini, understand Harini? Where is your brother Johan? Make it fast. Any doubt, can ask me. Clear, Mitakshri? Now. Once it is over, then we'll move to the next concept. Clear? Yes, all of you? Now,
Yes, sir.
Yes.
all of you keep heading. The concept which you are going to study
Yes, sir.
next is the most important one. That is what we used to call as buoyancy. So yesterday, how many of you remember the properties of liquid pressure? Do you all remember that when you are going deeper inside the liquid, the pressure is increases, density increases, pressure is increases. At the same height, pressure is uniformly distributed in all the directions. What is that law called as? Anyone?
Pascal's law, sir.
Law. So that is all we all should remember. Now, if you have been remember all the properties of liquid, those who have not attended, you all need to know the properties. Now, the most important concept we are going to study buoyancy, or I can say buoyant force. Buoyant force. Both are same. You can remember buoyancy or buoyancy force or buoyant force, whatever it is. Buoyant force. Now, I have sent you an image in the group. So please kindly, all of you, see that image and tell me, is that image is this one or not? I want to know. Is that image is this one? Everybody?
Yes, sir.
Everyone? That is one. Now, observe very carefully. Definitely, when we are all used to experience this buoyancy. What is buoyancy? I will say. So, you can see that I am asking you the question. When you are swimming, how many of you know swimming? Let's at least, have you all know swimming? Have you all swimmed at least till now one time? Yes, please. Girls, boys, everybody. Do you all went for swimming? I am asking the question. Now, those who went for swimming, kindly remember, when you are swimming, you observe your body, you will feel very, very lighter than what your actual weight. Is it true or not? Have you experienced that? Yes, anyone?
Yes, sir.
All of you? So, when we are swimming, we will feel actually our body is less weight than what we are in the air. When we are standing outside in the water, what we are having, when we go inside, we will feel little less weight. So now let us come to same way. In this first picture, all of you observe the first picture. Let me take Mr. Hari Somar is trying to push an empty bottle deeper inside the water. So he is applying the force intentionally. So that is why they mentioned up. What they mentioned, see here, what they mentioned here. A force is exerting. What force it is, Hari? External downward force. Do you understand, all of you? Now observe, when you push an empty closed plastic bottle in water, then immediately when you release your hand, immediately what will happen? What will happen? The bottle will come and will float on the surface. Is it yes or no? Is it yes or no?
Yes, sir.
Yes. Even you can see
Yes, sir.
while you are bathing. I don't know about you. I will experience. Even I used to play sometime. If you have been placed your mug empty, inverted direction, if you will try to push inside the water, as soon as you release your hand, your mug will jump and will come to the surface. Is it right or wrong?
Yes, sir.
That is. Now, here also, Mr. Omar is trying to push an empty a plastic water bottle, and as it is going inside the water because of one reason. What is the reason? Because he is applying the external what force, guys? Downward force. Do you understanding, everybody? So the bottle is going downwards. Do you remember? I told you in the last class reason behind. What is the reason of liquid pressure? Anybody can tell? What is the reason of solid pressure? Solid is also having weight, and liquids also having what? Liquids also having weight. So this weight is only causing for force, exerting force, the exerting pressure. The pressure is causing by solids or liquids or gases only because of they are having weight. The weight means the pressure. Whatever the weight they have, more weight, greater pressure. Less weight, less pressure. And I told solids will exert only pressure on bottom surface. But if it comes to the liquids, liquids can exert pressure on what? Abhirami, Nitakshri, liquid can exert pressure in all the directions, understanding of the container. So that is what we studied in the yesterday's class. Now you tell me, as soon as whenever Mr. Omar is applying the pressure, the external pressure, the bottle is pushed deep inside the water. Now the moment when he removed his hand, immediately the bottle will come to the surface of water and it will float there. I want a response from you all. Now tell me, what is the reason behind it? So try to answer the questions from this activity. So please, anybody, you all people even experience this one. So can anybody tell me what is this? What is the reason behind?
Liquid pressures.
Yes. So liquid pressure, Mr. Hariseras, but it is acting what direction? That is what my question.
Upward
Upward
direction, sir.
That is what. So even you can see, if you are having now also empty water bottle, go and push in our water tank. You can see when we are pushing, we will feel that somebody is pushing from the downwards. We will experience that force. Do you understanding, everyone? So when we are trying to push the empty plastic bottle in a bucket filled with the water, understanding? When we push the bottle into the bucket with our hand, by applying external force into what direction, everybody? Downward direction. Do you understand it? And one question I will ask you, please respond. Always weight of the object will act what direction? Downwards or upwards or any other direction? Weight of the object.
Downward.
Downward direction. All of you should remember. So I am applying an external force here so that the bottle is pushed downwards. Now, when you all people, when you push the empty bottle, then you will feel as somebody is trying to push you from the downwards. That is what? Upward force on your hand. You will experience that surely. So push the bottle further down, till the bottom of the bucket. Now release our hand suddenly. If we release our hand suddenly, what you will observe? What you will observe, guys? Tell me what your observation. Immediately what will happen, Mr. Omar? Mr. Arun? Immediately the bottle will come where? Come to the surface of the water. So the bottle bounces back to the surface of water. How it is happening? Because of one reason. What is the reason behind? Anybody? Yes, please. What is the reason? The
Liquid
reason
pressures.
is upward force. So observe very carefully. Always the gravitational force will act downward direction. So as we know in second chapter we studied, any object is placed on the surface, the force is exerted on the ground. That is what? Weight of the object. So weight of the object always will act in what direction, guys? Downward direction. That is what? Acceleration due to gravity. Then immediately earth also will exert reaction force. So reaction force always in what direction? All of you? Upward direction. Do you remember that? The same way here, the weight of the object is always will act downward direction. That is what? Gravitational force. Now, if you notice it here, the gravitational force is equals to whom, Hari? Can you tell me? The gravitational force is equals to whom? Weight of the bottle. Do you understand, all of you? Please respond. The gravitational force, which is equals to weight of this bottle, which is always acting vertically upwards or vertically downwards? All of you should answer. Vertically, gravitational force
Downward.
will act vertically downwards or vertically upwards?
Downwards, sir.
Vertically downwards. When? But inside the water, if you'll notice it, the another force is acting on the bottle in the upward direction. Here you can see in the upward direction it is acting by the water. This upward force is by whom, guys? By water it is acting. Understanding? So this upward force is greater than the weight of the bottle. All of you should remember the upward force which is exerted by whom? Mr. Kaushik? Upward force by whom? By water is greater than weight of bottle. Weight of bottle. So that is why bottle is coming to the surface or it is settled down. Anybody? Is it
To
settled
come to
down
the
or it
surface.
is coming up? It is coming up. So that is what all of you should understand. So it will, whenever if I release my hand, it will be bounces back to the surface of water, because the immersing, when I am immersing the bottle in water, I am applying some force. What is that force? Anybody read here? What is the force I am applying? When the bottle is immersed, please respond. What is the force I am applying? When the bottle is immersed, I am applying my external force with my hand. As soon as if I remove my hand, then you can see the force exerted by the water is greater than the weight of this bottle, so that the bottle will come and will settle on this surface of water. Is it okay, guys? Everybody? Yes or no?
Yes, sir.
Now,
Yes.
from this you can see, I will cut these two figures and only third figure I will say. So that is what I am drawing here. So always let me take the external force which I am exerting and as well as weight of the bottle. Both will act in what direction? All of you should tell me. External force and as well as weight of the bottle will act in what direction?
Upward direction.
Downward direction. The force exerted by the liquid is acting in what direction? What direction?
Upward direction.
Upward direction. Now, that is only the force exerted by here water I am taking. If I am not taking water, any kind of liquid, the force exerted by a fluid in upward direction, upward force is only called as, what we used to call? Anybody? We used to call as buoyancy, or we can say upthrust. Any problem? Anybody? Clear, everyone? The force, once again I'm saying, the force exerted by a liquid, the force exerted by a liquid, in what direction? In what direction? Upward direction. Understand? From the bottom of the container is only called as upward force. Also, we can say one more word I am introducing for your purpose. Also, we can call it as up thrust. Is it okay, everyone? Hariseras, Umar?
Yes, sir.
Now all people knows. I taught you.
Yes,
Thrust
sir.
means what? Can you tell me what do you mean by thrust? Thrust is a type of force which is acting perpendicularly. Yes or no?
Yes, sir.
Yes, sir.
Now, here also thrust is acting, but what direction it is acting? Have you noticed it? It is acting upward direction, perpendicularly. That is why it is called as, what is to call? Up thrust, or also we can call it as buoyancy. I hope everybody understanding. Kaushik, Harini, buoyancy, or I told you buoyant force, buoyant, buoyant force. So any doubt anybody is having in this, please let me know. This is what we used to call as buoyancy concept. Hope everybody clear. And this diagram is already there in our classwork. Sorry, in our group, you all should draw this diagram in our things. Now, you tell me, I will ask you one question. As we know that here F2 and W both are acting in what direction? What direction? Downward direction, and F1 is acting upward direction. Remember, here F2 and W are both are in same direction. That is why that force is equals to F1 force. Is it right or wrong? Harish? Hitakshri? Yes or no?
Yes.
Action is equals to reaction. Is it true or not? So can I say now, all of you, F2 plus W is equals to F2 plus W is equals to F1. How many of you will accept it? Is it right or wrong? Yes?
Yes, sir.
Now, weight W means what, guys? Anybody can tell what do you mean by W? Weight of the bottle. Weight of the bottle means the force exerted by the bottle. It is what towards to gravity, downward direction. So this is what I can say. Now, how much Omar is applied force? Can you tell me how I found? How much external force is Omar is applied? Can anybody tell me? What is the force applied by Omar? I want answer. So the force applied by Mr. Omar, F2 is equals to F1 minus W. Is it right or wrong, Mitakshri? Can I find it?
Yes.
Yes. So F2 means what? All of you should tell me. F2 means what? External force applied in downward direction, which is equals to F1. What do you mean by F1? All of you? What do you mean by F1?
Upward pressure.
Buoyancy force, or we can say upward force minus W. What do you mean by W?
Weight of the body.
Of the whom? Weight of the
Bottle.
body, or we can say bottle. Understand, Mr. Kaushik? Mr. Akilan, Gokul, this is how you must find the external force applied by a body to push the body downward direction. Hope anybody is having any doubt, please let me know. Or else, please remember this diagram you should draw. And now I will say the definition of buoyancy, right? This one also please remember. F1, F2 means external downward force. W means weight of the bottle equals to F1. F1 means upward force. So why I am considering here F2 and W together? Anybody can answer? Why F2 plus W is equals to F1? Anyone? Because F2 and W both are acting what direction?
Downward direction, sir.
Downward direction. That is why they are same direction of force. And F1 is acting opposite. That is why it has been considered opposite. Is it okay, guys? Mitakshri, Divya, are you clear?
Yes, sir.
Yes. So please note it down till here. Just 2 minutes time. Then I will say the definitions. So what is another name of buoyancy force? Buoyant force. What is another name of buoyant force? Up.
Upthrust.
Remember, if force is acting perpendicularly to the surface, if this is the surface, if the force is acting perpendicularly like this, that is called as thrust. Okay. Now, if the force is acting upward direction perpendicularly, then that is called as upthrust. So upthrust is shown by fluids, thrust is shown by solids. Is it okay, everybody? So always remember, weight of the object is always act what direction? Weight of object is only force. So weight of object is always act what direction, guys? Down.
Downward.
Downward.
Okay, and upthrust will act always upward direction. The pressure exerted by a liquid always act in upward direction. The pressure exerted by weight always will act downward direction. Is it okay, everybody? Yes, please. So that is what you have to remember. You can draw one diagram, small diagram, and represent downward force. Suppose if you consider this is the center, the downward force is the weight of the object, understanding, and upward force is the FB. FB means what? Anybody can tell? FB. What is that FB means? FB means what, guys?
Buoyancy.
Buoyancy force. So like this you can represent. That is what. See here. Buoyancy force. 1 minute. Buoyancy force is upwards like this, and downwards is weight of the object. So you all people represent like this. Is it okay, guys? Yes, please.
Yes, sir.
Okay, so anywhere anybody is having doubt, please kindly know. So this equation is over, everything is over, hurry. You can write external force is equals to upthrust force minus weight of the bottle. That statement you have to write it. Okay, guys. So once it is over, so I will say always, basically if I take any kind of object, please remember, always the weight of the object is acting downward direction. And if I'll consider the center, please make it everything. So if I will draw, always the buoyancy force is acting upward, FB, and weight of the object, if you'll notice it, that I am drawing downwards. So weight of the object from the center, you can see. So weight of the object is always acting what direction? Weight of object. Okay. Weight of object is always acting downward direction. Now from the down, some force is acting upward. Who is that force? FB, buoyancy force. So this is what you have to remember. Okay. Harizeras, Johan, understand? Kaushik?
Sir.
That is. So please,
Yes, sir.
everybody, Divya, any doubt, Divya, in this concept? Write the definition now. And those who are absent in yesterday's, please learn the derivation as it is very important. Right. The upward force, equation you should write first. So as we know, F2 plus W is equals to F1. Now F2, external force is equals to F1 minus W. F2 means, right, please, external applied force is equals to upward force minus weight of the bottom. Okay, the diagram, please draw all of it right now. The upward force exerted by the liquid. Now you tell me, for example, if this is the beaker, now till here water is there. Till here water is there. Now Mr. Omar is holding the bottle above from this. Now is it buoyancy force is exerting? Is it the buoyancy force is exerting? No, touch the liquid. Have you noticed it? All of you? Is the buoyancy force is exerting now? I want to answer from you all. Is it buoyancy force is exerting? Mr. Harish?
No, sir.
No. Remember, only buoyancy force exert when a body is immersed inside the liquid. Do you understand, everybody? Only when the object is immersed inside, only you will experience the buoyancy force. If you are out from it, no external force on this. That is you have to remember. Okay. So body should immerse inside the liquid, right? The upward force exerted by the liquid, on a body immersed in it, Immersed in it. So immersed means what? It should be pushed inside. It has to be go inside. Then only buoyancy force will exert. If not, no buoyancy. Clear? Yes? Okay, write the definition fully. The upward force exerted by the liquid on a body immersed in it, is known as upthrust or buoyant force. Buoyant force. What is the spelling of buoyant? Upthrust, or we can say buoyant. Buoyant force. Okay. Next, right. Buoyant force. Thus, the tendency of a liquid, the tendency of a liquid to exert an upward force, on a body which is above or is immersed. Anybody?
Immersed.
A body immersed partially or completely. Partially also it will be exerting. Partially or wholly, we can say. Wholly means fully. Wholly in it. In it is known as, what was to call? Is known as
buoyancy,
buoyancy. So you have to remember all the liquids possess buoyancy. But buoyancy depends on two things. Again, factors. Write it. The magnitude of upthrust depends on, or else you can write factors affecting buoyancy. Factors affecting buoyancy. Bracket you write magnitude. What do you mean by magnitude? So many days I am teaching. Can anybody tell me what do you mean by magnitude? Magnitude of upthrust. Yes, please. Magnitude means number. How much? Because as we know, upthrust means it is also what? Force only. So buoyancy force. Magnitude means how much quantity. Understanding quantity it is exerting. Because like 10 newtons, 100 newtons, 1000 newtons, like that, this number is called as, what is this number called as? All of you is called as magnitude. Okay, everybody. So that is what? Magnitude of upthrust. First factor, density of fluid. What is the first factor, everybody? Density of fluid. Okay. So remember, density, what is the symbol will represent? Everybody. Density.
Rho.
Yes. Density, rho. Rho is directly proportional to buoyancy force. Gokul, okay. You're writing network problem. Please write. Buoyancy force. If density, you can write full form if you want, if not understanding. Rho, it is symbol is rho. Density increases, then buoyant force also increases. So vice versa. Vice versa means if it is decreases, it is also decreases. Is it okay, guys? Yes, please. All of you.
Yes, sir.
Yes. Next. The volume of the fluid displaced by the body. The volume of the body, sorry, the volume of the fluid, by the body. So now this factor just you learn when we are studying the next concept. By the time I will explain this one. Is it okay, Harry? When we are studying the Archimedes principle, I will explain you this second factor. Is it okay, all of you?
Yes, sir.
That is. So till here, please kindly complete it. When I am
Yes, sir.
teaching the Archimedes principle, please make me reminder. The second point I will explain you clearly. So now if I teach also, you will never understand unless Archimedes principle. So these are the two factors which is affecting the magnitude of that one. So first factor, if you want example, for example, see this example I will say. Example, iron will sink in water, but iron will float in mercury. Because what is the reason, guys? What is the reason? Anybody?
More density, sir.
The density of mercury is 35.
Water
Density, sir.
density is 1 gram per cubic centimeter or 1,000 kilogram per cubic meter. Mercury, if will come, mercury density